Hello, this is Paul from Foresight Tech. In this lecture, we're going to introduce the last type of trig substitution here, okay, which is square root of a square plus x square. The last one with this a square x square minus a square, right? Or a square minus x square. This time is a square plus x square, and a is positive. And look at here summary. What type of for this integral, what type of substitution and suggested, which is the tangent, but don't miss a. So x is a times tangent, and the domain for theta is between negative power 2 to power 2. Okay, and the identity we need to use is this Pythagorean. So first, the same. We're going to see if these two are consistent for the range of x. So first, resolve this. X could be any real number, right? Okay, the domain should be all the real number. And then if we draw a graph for tangent, everyone know this famous, right? Tangent is increasing between negative power 2 to power 2. So which means what? If theta belongs to this for x, so it's go from negative infinity up to positive infinity, which means all the real number we can get for x. All the real number, they are consistent, definitely. Okay, and then I'll show you here. See, from this, so you will see why we need to do tangent. Okay, we're going to the complicated integral first. Square root of a square plus x square. If we use this suggested substitution, plug in, we will get this. And the a square factored out, we will get this. 1 plus tangent square is secant square, Pythagorean identity, right? And now take square root. Okay, square root of a square goes back to a times secant. Why secant is positive? You can look at it. You can imagine theta belongs to negative pi or pi, which means q4 or q1, right? Quadrant 4 or quadrant 1, and cosine quadrant 1, quadrant 4 are both positive. The reciprocal secant is also positive. Definitely here's no negative. This is very easy, right? Now I will show you only one example. So how do you use this substitution? And the method is very organized. Okay, it's very well known. It's a well known method. So we're going to definitely the integral is the type by square root of a square, or if you say so you can see this. Okay, square root of remember is a square plus x square. What is a? We can see this time a equals 2, definitely. Okay, now we do this substitution. We substitute x equals a, which is 2 times tangent, right? Okay, theta. And also the domain for theta is belongs to negative power 2 to power 2, cannot equal because tangent has no definition. Okay, there. And then we're going to find the dx for the substitution. And then dx equals, take a derivative is 2 times secant square theta. And then don't miss d theta. Okay, don't miss d theta. The second, we're going to simplify this integral for this square root 4 plus x square. Do you remember we just did, which means a times secant was a 2 times secant theta. Now everything is ready for the substitution. I just plug in the original square root 4 plus x square dx equals what? I plug everything. So 1 over the bottom is already goes to 2 secant theta, right? dx already goes to here. I copy. Okay, now you know simplify, right? So this simplify is super easy. After you simplify, you get secant theta, d theta, and this is definitely, remember. So we already know this, right? From 7.2. Okay, the trig integrals. Okay, from that, what is the final results? There is ln secant theta plus tangent theta. We use these results for a lot of times, so I hope you already remember this. Okay, and then plus constant number. Don't miss the last step. You know, is back, right? Is back substitute to get x. How to get this? You remember the common method. We were going to from the original tangent theta build the right triangle. Use the right triangle definition to find this. So I'll show you here. Was the one? So the original x equals 2 tangent theta, right? We solve tangent theta first, and then we see x is the opposite, 2 is the adjacent to build the right triangle. Okay, I put the theta here. So these put the x, these we put the 2. Now we can solve the hypotenuse, which is what? Hypotenuse, which is 2 squared plus x squared, which is 4 plus x squared. Now we have everything, right? And the right triangle is here, so we have the value for this, trigonometry. Okay, from the trigonometry, directly we will find after substitute we have this. Secant is hypotenuse over adjacent. Hypotenuse is this 4 plus x squared. Adjacent is 2 plus. So now the tangent, right? So what the tangent? The tangent is opposite over adjacent. Opposite is x, adjacent is 2, and then plus c. You remember this, right? So I can move on. You remember this? We can go into simplify again. Okay, simplify that again, and I skip one step because we did exactly the last example, and then we're going to get LM. Use the quotient. So keep in mind, use the quotient rule of log, right? And then we have two constant number. We put it together. What do we get? We will get here is a square root 4 plus x squared plus x minus, okay, I put this as the rod here, minus ln2, and then plus c, remember? And we say these we put it together, called the c1, right? Is a negative ln2 plus c, and then you can write one more step. And can you see all this? That's all for these questions. Thank you.